So in this video, I am going to review the answer from my previous YouTube video, which was related to AS Physics Practical Part 1. If you have yet to watch my previous YouTube video, which was related to AS Physics Practical Part 1, you can actually refer to the description below. Link is already attached. So I want you to see this. Ta-da-da-da! This is my digital voltmeter. So can you see that the reading on the voltmeter keeps on fluctuates? And how do I make it stop fluctuating? Is that very simple? All you need to do is just to make sure the connections are tightened. All you need to do is just to make sure the connections between the wires and the voltmeters are tightened. That is how you stop your digital voltmeter or your digital ammeter from being fluctuated. Did you get the correct answer? In this video, I am going to continue to talk about physics, AS Physics Practical, which is related to paper 3, question number 2. This is the second part of the AS Physics Practical. First of all, you have to understand the popular questions that are always pop up in your physics, AS Physics Practical, question number 2. So length measurements is one of the very popular questions in second question. Diameter measurements is also quite popular. Angle measurements, as well as period measurement. We are going to look into all these measurements one by one. And I need you to stay until the end of the video because I will be giving you some bonuses, which is related to limitations as well as improvements. That's one of the problems. Those are the problems that faced by most of the students in scoring full marks in paper 3, question number 2. So let us begin. First of all, let us talk about the length and diameter measurement. All you need to do is to take note on. First, always make sure that you record your readings by following the DP of your apparatus. DP means decimal places or decimal point of your apparatus. And you have to make sure that your eye level is always perpendicular to the scale on the apparatus, as well as to repeat the measurements, as well as to find the average at the same time. I give you some example. So let's say one of the questions is related to the length measurement, and the apparatus given is your meter rule. And they ask you to measure and record length, L0, which is related to length, and the apparatus given is your meter rule. So how are you going to do about that? First of all, you have to identify the smallest division on your meter rule or the sensitivity on your meter rule. So the sensitivity or the smallest division of the meter rule is 0.1 cm. Or I can also say the absolute uncertainty of your meter rule is plus minus 0.1 cm. But hey, stop right there. Look at the units given here. This is in meter. That also means that the question wants you to record the reading in meter. So how do you go about that? All you need to do is just to convert the smallest division or the sensitivity or the absolute uncertainty of your meter rule to meter. So if you want to convert cm to meter, all you need to do is just to divide 100. So you just shift to 0, 1, and 2. So the absolute uncertainty of your meter rule is 0.001 meter. This is 3 decimal points. Whenever you take your measurement, let's say the measurement on your meter rule is 15.7 or cm. All you need to do first, take this reading, change it to meter. You just divide it by 100, shift to 0, 1, 2. So you get 0.157. So 0.157. Since the absolute uncertainty has 3 decimal points, your readings must be recorded as 3 decimal points as well. That is how you gain mark. The next one is about period measurement. So what you need to take notes are, first, you have to take more than one oscillation. And wherever you record the time reading, you have to record the time reading according to the sensitivity of the stopwatch. The stopwatch that we are using in our lab is a digital stopwatch. And I definitely know that the sensitivity of the digital stopwatch, or the absolute uncertainty of the digital stopwatch, is plus minus 0.01 second. But the problem is, we human, we are not that fast to react. So due to our humans' reaction time, since we are not fast to respond, you have to increase the absolute uncertainty of the digital stopwatch. So you have to increase it to 0.1 second. All the readings recorded by a digital stopwatch must be recorded in 1 dp, or 1 decimal place. So, okay, if you take more than one oscillation, do you know why we need to take more than one oscillation? Because we actually wanted to reduce the human reaction time, because you have to release the pendulum, for example, and then press the stopwatch at the same time, which would definitely increasing the error in measurement, because we might be pressing the stopwatch a little bit faster or a little bit slower. That is why we take more than one oscillation. Let's say we take 10 oscillations. To find the period, all you need to do, record the time taken for 10 oscillations divided by 10, divided by the number of oscillations. That will give you more accurate period value. So period is measured in seconds. Example, take measurements to find the period T of the oscillation. I want you to look at the marks allocated here. The marks allocated here is 2 marks. That means 1 mark will be given for the repetition. So I take, okay, time taken for 10 oscillations or 5 oscillations. Is actually up to you, as long as it is more than 1 oscillation. So let's say I have T1. You have to show that you repeat the measurement, which is maybe 22.2 seconds. Make sure that all your time measurement must be recorded in terms of 1 decimal point. And T2, which is maybe 22.5 seconds, for example. And after that, you find your T average, which is equal to T1 plus T2 divided by 2. T1 is 22.2. T2 is 22.5. All you need to do is just to divide by 2, because you just repeat twice. I'm going to do it right now. Plus 22.5 divided by 2. And I got 22.4 seconds. That's my T average. So to find period is your T average divided by 10, because you took 10 oscillations. So it is 22.4 seconds divided by 10, which is 2.24 seconds. That is how you calculate your period. Period cannot be measured, but can only be calculated. And since period is the calculated data, you have to follow the significant figures of its raw data. So the raw data are actually the data or the readings taken from the apparatus. So since the raw data has 3 significant figures, that is why my period is recorded as 3 significant figures. The next one is about angle measurements. So what you need to take note? First of all, make sure that your eye level is always perpendicular to the scale on your protractor. Second, make sure that you repeat your measurements and find the average at the same time. After that, and normally the protractor that was given in the lab is more like a transparent protractor. So if it is transparent, normally it's very hard for us to judge or to judge the accurate reading. Most of the time, if you want your reading to be more accurate, all you need to do is just take out your question paper, place it behind the protractor. When you take the reading will be more accurate. Example, measure and record data. If you're using protractor to do your measurement, all you need to do is just to look at the protractor. What is the sensitivity or the smallest deviation or the absolute uncertainty of protractor? It is 1 degree. So all the readings recorded by protractor is without decimal point. It is either 22 degree, 23 degree, 1 degree, 2 degree, etc. The next one is about estimate percentage uncertainty. Normally, you need to increase the sensitivity of the measuring apparatus because paper 3, AS Physics paper 3, question number 2 is an experiment which is full of errors. So let us look at one example right here. I want you to see this. This is a diagram given, and you are asked to estimate the percentage uncertainty in D. So you have to recall what is the equation of percentage uncertainty. So the percentage uncertainty in D, I will write percentage uncertainty of D is equal to delta D over D times 100%. But what is delta D? Delta D is actually the absolute uncertainty of D. Absolute uncertainty of D is actually related to the sensitivity of your measuring apparatus. That is what they ask you to estimate. You have to estimate this one. So, since we are supposed to use a meter rule to measure the distance, but when you look at the diagram, where are you going to place your meter rule? Of course, I'm going to place my meter rule right here. So if I place my meter rule right here, there's a certain distance between this marble and the readings on the meter rule. So it makes it very hard for me to determine the accurate reading of D. Do you notice that? That is why you need to increase the absolute uncertainty of D, because you definitely know that this kind of measurement is very, very inaccurate. So it actually depends on your logic sense, because there is no certain answer of how much the percentage of D must be. But if you think that the error of the measurements is quite large, you could increase to a larger value for the absolute uncertainty of D. But if you think that the measurement is just the error is not too large, then you could increase just a little bit. For this case, I would say that because the marble there's a distance between the marble and the meter rule and the scale on the meter rule. It is very hard for me to look at the marble and judge the scale on the meter rule. That is why I would like to increase my delta D. Okay, let me state it first. The smallest division on the meter rule, or the sensitivity of the meter rule, is 0.1 cm. That is why the absolute uncertainty of the meter rule is 0.1 cm. But for this case, since the measurement is really not accurate, I would like to increase my absolute uncertainty of my meter rule to be plus minus 0.2 cm, because I think that I still can measure. It is just that not so accurate. But if you think that the error of the measurement of D will be quite large, then you should increase to maybe 0.5 cm. That would do. Now, another example is that, first, look at this ball. It's being dropped at 40 cm, hit a ramp, and h is actually the rebound height of the ball. So when even if I place, because there's no clamp for me to place to clamp my meter rule, because the ball might be knocking on my meter rule, all I need to do is just to place the meter rule as close as possible to the ball, but not touching the ball. So to measure something, the height of the rebound ball, of course, I could not detect it because I have to look at the scale on the meter rule as well as to detect where it will rebound to. So I have to look at the rebound height and make sure that my eye level is perpendicular to the scale on the meter rule to avoid the parallax error. So I would say that percentage uncertainty of H is delta H over H times 100%. So I would like to increase my delta H to be plus minus 0.5 cm because I think that the ball is moving too fast. It is very hard for me to detect the height, the rebound height. Now, another one is about justification. Justification is just showing proof. So you have to show the proof from your calculations, then only you give your explanation. For justification, there is no right or there's no wrong answer. As long as you show proof, you show from your calculation, and you give a logic explanation to that, you should be able to gain full marks. Example. I have an equation here. S is equal to ml squared over 12. And it asks you to justify the number of significant figures that you have given for your values of S. And it is 1 mark question. What you need to do is that after you have calculated your S must be calculated from M from L square or just L, doesn't matter. So you have to look at the significant figures of M, significant figures of L. If, let's say I give you an example, M has 2 significant figures and L has 2 significant figures, then you can put 2 significant figures for S. But if M has 3 significant figures, L has 2 significant figures, then it is up to you to judge. Maybe you want to put it as 2 significant figures, or maybe you want to give 3 significant figures to the value of your S. It doesn't matter. As long as you show, since M has, let's say, 3 significant figures, L has 2 significant figures, hence S can take 3 significant figures or 2 significant figures. It is up to you, as long as you show the proof. Now, the next one is about how to calculate the percentage of K values. Normally, the second question is related to the first experiment first, and then you have to repeat twice to get different K values. So just use this equation rule 2. You need to calculate the percentage uncertainty of K. This is the equation that you can use to calculate the percentage uncertainty of K. I put a modulus here because I want the difference to be positive. That is why all you need to do is just to take the K value, the larger K value minus the smaller K value, divided by smaller K values and times with 100%. Example, it is suggested that the percentage uncertainty in the values of K is 15%. Using this uncertainty, explain whether your results support the relationship in D, for example. If the percentage uncertainty of your K is larger than 15%, but you have to show the proof by calculation. So this is a blank space for you to show your calculation. K1 minus K2, I put a modulus because you have to take a larger value minus a smaller value divided by the smaller value of K times 100%. If the percentage uncertainty is more than 15%, then your result does not support the relationship. If your percentage uncertainty of K is lesser than 15%, then your result supports the relationship in D. You have to explain it. Now, the next one is about limitations, right? Limitation is actually the problems that you encounter during the experiment in the lab and cannot be solved immediately. For example, you are given a meter rule to measure the thickness of a few pieces of paper, maybe 10 pieces of paper. Do you think using a meter rule to measure the thickness of the papers will be as accurate? No, right? But you are not given the correct apparatus to do your measurement. The correct apparatus to be used to measure the thickness of the paper is either vernier calipers or micrometer screw gauge. That could be one of the limitations that cause your readings to be very inaccurate. So you can talk about that. That is called limitation. And most of the students, they will write it as very hard to get. Let's say you're supposed to measure H or rebound height, for example, very hard to get the accurate H value due to air resistance. And since you are asked to state limitations, of course, you are asked to give improvements to the limitations that you have stated. And since you have stated that due to air resistance, your measurement of H cannot be measured as accurate as possible, the improvements, when I saw the improvements was about conducting the experiment in vacuum. First question appeared in my mind is that how are you going to breathe when you conduct the experiment in vacuum? And we don't really have vacuum chamber in our lab. So that is not the right limitations or improvement to be stated. So one of the general limitation which you can state, which is valid for every question in AS Physics Practical, paper 3, question number 2 is that 2 readings are not enough to draw a valid conclusion. Memorize that. And improvement is for you to discuss on how to make your experiment more accurate. So the general improvement is that take more readings, plot a graph to see the relationship. Memorize this as well. Now, remember what I told you? I asked you to stay until the end of the video because this is a bonus thingy that I'm giving you. So I'm going to give you the suggested limitations and improvements to give you more idea in writing your AS Physics Practical Paper 3, question number 2. So the first one, if this is about the cylinder that is made of clay, you are supposed to roll the clay into the shape of the cylinder. And all you need to do, you have a slope or a ramp to roll the cylinder down. Okay, so what are the limitations or the improvements that you can write? First, limitation is the general limitation, which you have to memorize. 2 readings are not enough to draw a valid conclusion. Improvement is that you take more readings, you plot a graph to see the relationship. Don't just say take more readings and find the average, because that is not an improvement. And that is definitely not the limitation as well. Because when you conduct the experiment, you know that you can take more than 2 readings if you want. And you can find the average if you want. That is not your limitation. And that is definitely not improvement. And the next limitation could be maybe because we are given the clay and it's very difficult to make the accurate shape of the cylinder. So I will say that instead of asking me to make the shape of a cylinder, why not you just give me a PVC cylinder or the cylinder that come with the correct shape. And the next limitation is maybe when you roll the cylinder down, because this cylinder is made of clay, the cylinder does not roll straight. It might roll at a certain angle. So all you need to do to improve it, maybe you can use a longer, smooth ramp so that it can roll down straight smoothly. And the last limitation could be difficult in judging the end point of where the cylinder stops rolling. Improvement is that you use a ramp, right? You could mark the starting point and the end point on the ramp using a marker. And then you just place the cylinder on the starting point, and when the cylinder reaches the end, you just stop it. And the next one maybe is related to rebound heights of a table tennis ball. So these are the limitations. So the general limitation is always that 2 readings are not enough to draw a valid conclusion. Improvement could be take more readings, plot a graph to see the relationship. And since this is about a rebound height of a table tennis ball, it is really hard to measure the rebound height as the ball moves too quickly. So all you need to do is that maybe you could use the video camera from the lab, take the video, record it, and you play back frame by frame. This is a very important word to be used. You cannot just say play back, but you have to play back frame by frame. The next limitation could be parallax error in rebound height, because I have to move up and down. And how sure that my eye level is perpendicular to the scale reading? Because I have to determine the height of the ball and I have to look at the scale on the meter rule at the same time. So it's very hard to do so, right? All I need to do is that I let go of the ball, let it rebound first. I roughly know the height of the rebound height of this ball. I take a set square and I place the set square as a guide on the scale of my meter rule. Then only I take the reading on my meter rule. And the last limitations could be inconsistent bound of the ball due to the condition of your bench. All you need to do improvement is just to make sure that the surface is flat. Now, that is all for now. If you need the PDF answer for this slide, you could join my Facebook group. All you need to do is just to answer 3 questions and you will be approved. So I see you in my next video.